Going to be talking about global warming with Dr. Cassie Garton from the Rosenstiel School of Marine Sciences here at Miami.
Hey Cassie, how you doing?
I'm good. How are you?
I'm good. Listen, thanks for joining us. I hope the IT wasn't too difficult.
No, it's just new stuff for me. I haven't really done this before, so.
All right. Well, it looks like you're a pro now. So again, thanks for joining us. I'm going to do a brief intro just while everyone's logging on.
Okay.
We are lucky to have Dr. Cassie Garton. Is that how you pronounce it? Garton?
Gaston.
Garton? Oh, Gaston. Okay. Sorry about that. She's an assistant professor in the Department of Atmospheric Sciences at the University of Miami's Rosenstiel School of Marine Sciences. She's an expert in atmospheric chemistry, specifically in aerosols, trace gases, and their interactions. Cassie's lectured extensively on these topics. She's mentored undergraduate and graduate students, guided them both in the lab and in the field, and has several high impact publications. And again, like I said, we are lucky to have her today joining us, talking about the ever controversial topic of global warming, climate change, and what does the future look like. So again, thanks for joining us.
Absolutely. Thank you for having me.
So we'll just start by talking about your research, which is so interesting and so cutting edge. Just talk about what your research looks at and how atmospheric chemistry does relate to climate change.
Sure. So as you mentioned, my expertise is in aerosols. And for those of you who aren't familiar, aerosols are basically just teeny particles that are suspended in the air. So think of like a grain of sand, but much smaller than that. And we actually have a lot of familiarity with them these days because they're responsible also for the airborne transmission of the virus responsible for COVID. And that's why we've been wearing masks. And so I'll get into the details more, but these aerosols can also affect climate. They affect precipitation and weather. They affect clouds. So we know on a cloudy day, the temperature feels very different than on a cloud-free day. They also can deposit and fertilize the health or the oceans and forests. And that also has implications for the carbon cycle and the uptake of carbon dioxide out of the atmosphere. And so in terms of atmospheric chemistry and how that relates to climate, so in addition to these aerosols, we also think a lot about greenhouse gases, and something that atmospheric chemists are really well equipped to do is we're very good at measuring the emission and the loss processes of these gases with very high precision. And we can also develop chemical tools to fingerprint where these gases come from. So how do we know that the accumulation of carbon dioxide in the atmosphere recently has been from anthropogenic sources? That's something that we can fingerprint as atmospheric chemists.
Interesting. And talk a little bit about climate change and global warming. People kind of associate those two as being the same, but they're not. Just what's the difference between those two?
Yeah, so the difference really is scope. So global warming just focuses on the temperature increases that the Earth has experienced since the Industrial Revolution, whereas climate change encompasses that temperature increase, but also provides more regional consequences of that temperature change. So for instance, how has precipitation changed? How has sea level rise been affected? How have storm frequencies and intensities changed? How has the propagation of disease changed? So climate change really encompasses both the cause as well as the effects, whereas global warming is just more focused on the cause.
Got you. Now, you're obviously one of the top people in your field. And what brought you to Miami, and why the Rosenstiel School, which is obviously one of the best in the country, but what in particular drove you down here?
Yeah, there was a lot of reasons. The number one reason for me was the people, honestly. I really felt welcomed from the moment I interviewed in the Department of Atmospheric Sciences. My colleagues have just been so kind and so welcoming to me. I collaborate with a lot of them. I also collaborate with ocean chemists and geochemists, which is typically not easy to do at a lot of universities, but Rasmus makes it really easy, which makes the science A, more enjoyable, and B, more impactful. The students are also fabulous. So I've had the great fortune of mentoring some really high quality graduate students and undergraduates. A lot of our undergraduates it's almost like having another graduate student in the lab. They're really fantastic and very, very capable of producing very high impact research. I've also published with a lot of my undergraduates from which is not something that's easy to do and not something that you can do at every institution. I also really like how the university is very focused on interdisciplinary research. So the new initiatives like ULink, the University Laboratory for Integrative Knowledge, that has really led to some really powerful collaborations. So I've collaborated with folks on the medical campus to look at the health impacts of harmful algal blooms with those kinds of initiatives. And that's not something you can always find at other universities. And also we have really unique resources. We have an atmospheric tower in Barbados, and that's where we do a lot of our measurements. And this is a one-of-a-kind resource that you wouldn't have access to at other places.
So you mentioned that tower that's in Barbados. Are you guys expanding throughout the Caribbean? I feel like that's an untapped resource when you're talking about atmospheric sciences.
Yeah, so one thing that we've been doing is we've been partnering a lot with different scientists throughout the Caribbean. So I'm part of this Caribbean Aerosol Health Network that partners with air quality specialists all throughout the Caribbean. And then we also partner a lot with air quality specialists in South America as well. So we're really connecting North America to South America and the Caribbean through a lot of our research.
So let's move into global warming. There's been some controversy. I don't know if it actually is controversial, but how unequivocal in your mind, and according to the science and the data, how unequivocal is global warming?
Yeah, unfortunately, it's unequivocal in our field for climate science, atmospheric science. You know, the scientists who study this particular field, there's no question. So the latest IPCC report basically gives, you know, our understanding a very high level of confidence that climate change is unfortunately human induced. And remember, like, these reports are written by hundreds of scientists that have to come into agreement about the language used. So that's pretty high consensus.
And so I guess the next question is, most people would say, well, you know, so what? What does global warming have to do with me? Talk a little bit about the effects of global warming on the world we live in. Heat waves, droughts, flooding, extinctions, etc.
Yeah, and this is where the distinction between global warming and climate change actually becomes important, because when we say global warming, sometimes people use that as a misnomer for saying, like, well, it doesn't feel any warmer today when I step outside, so how is this even happening? And this is where climate change is actually a more appropriate term, because we are starting to see a lot, because we're thinking about those impacts that are regional, that do affect all of us. So for instance, you know, for people who live up in Alaska, we are seeing shrinking of the polar ice caps and other glaciers. For people who live on the western parts of the US, we're seeing extreme droughts, and this is promoting wildfires. And then for those of us who live in the Midwest and in the eastern parts of the US, we're seeing extreme flooding, we're seeing precipitation, we're seeing intensification of storms. So for those of you who are in Florida, you'll probably remember the unusual 2017 and 2020 hurricane seasons. Storms are also getting slower and holding more water. So for those of you living in Texas, you'll remember this with Harvey, where it wasn't that the storm was so intense, it's just that it sat there and it dumped so much water. We're also seeing increased conflict for resources, increased climate refugees, increased propagation of disease. So it really has had a real tangible impact on us, no matter where we live.
And let's talk about something that is very pertinent to here in South Florida, sea level rising, basically global warming, melting of the ice caps. How significant of a problem is this, and how much time do we have? People say, well, it's not going to affect me. Like, what timetable are we looking at for a significant change in sea level that's going to impact South Florida?
Yeah, that's a really good question. So this is a really significant impact, and you know what my colleagues who are glaciologists have concluded is that, you know, the ice caps and also the ice sheets in Greenland are melting a lot faster than we had expected. And this is because it's not just melting on the surface of the ice sheets, but we're actually seeing cracks in some of these glaciers. So when you crack the glaciers and also get meltwater that pours into those cracks, it makes it easier for those sheets to slide into the ocean. And so this is happening at a much faster time rate than a lot of us had expected. And this is going to have major impacts on not just sea level rise, but also on atmospheric circulation patterns. And also have to think not just about sea level rise, but also polar ecosystems, impacts on native cultures that live in those regions. I also want to mention that it's not just the ice caps that we have to think about in sea level rise. So if we think more globally, there's also glaciers in other parts of the world that don't get mentioned enough, but the impacts are very real. So there's loss of glaciers that provide a source of clean water and a source of agriculture for millions of people. And most evident is in the Himalayas, where glacier retreat is going to affect millions of lives through access to basic human needs like food and water.
And I mean, are we talking about a year, 10 years, 100 years? How impactful within our lifetime are these changes?
Yeah, so I think the best people to speak on that are some of my other colleagues at the Rosenstiel School who actually model this sort of thing. I mean, the projections that I've heard are, it's really going to depend on where you live. So the timescales for people closer to the coast is in the decades. People who are further inland, it's going to be in the tens of decades to possibly 100 years. But again, I'd probably refer you to some of my other colleagues at the Rosenstiel School who could provide a more accurate answer.
Yeah, I mean, either way, it sounds like it's certainly not in the too distant future from what you're saying. So obviously a very, very important topic. So we talked
Yeah.
about kind of climate change, global warming, and the reasons for it. And so what I've been reading is that the number one factor is human footprint, like you were saying at the beginning, and the burning of fossil fuels. Explain, is that the number one cause of climate change, global warming? And what can we do about that?
Yeah, it is. So as atmospheric chemists, we have developed tools to fingerprint the greenhouse gases that are in our modern atmosphere. Another thing that we do is we actually take ice cores from places like Antarctica and Greenland, and then those ice cores actually preserve records of the paleo atmosphere in their bubbles, and we can measure the gas phase composition and look at what the paleo atmosphere looked like in the past. So we do know that we're seeing an unprecedented level of warming in at least the last 2,000 years. And we can use things that are akin to carbon dating for the air in the atmosphere to attribute it unequivocally to a fossil fuel source. In terms of what we can do, there's really no one silver bullet, but there's a lot of things that we as individuals can do. I think one of the most important things that we can do is we can vote. We can, speak to our representatives and tell them our concerns, tell them what we'd like to see for our future, for our children's futures. Other things that we can do is, try to reduce our own carbon footprints, reducing our waste, turning off the lights when we're not using a room. Simple things like that really do add up. Trying to reduce the amount of travel that we take, things like that. But really, I think the number one thing that we can do is to make our voices heard in the political arena. I think that's a really important way to help tackle this issue, and also to get more involved in thinking about renewable energies. There's a lot of technology out there that I think can really help us out of this. And I think we just need to, be more active about, encouraging the development of those technologies.
So I want to go back to your research because I find it so fascinating. Just talk a little bit again, just for the layperson, what are aerosols and how do they affect the Earth's climate, and what can the average human being do to make an impact in that arena?
Yeah, that's a great question. So as I mentioned, aerosols are basically these teeny particles that are suspended in the atmosphere, and they can come from a variety of sources. They're not just man-made. So they come from the ocean, they come from the deserts, those are natural. They also come from cars and ships. And then they can even come from our mouths when we speak or exhale, right? And these can directly impact incoming energy from the sun. So think of a hazy day. This can maybe have a cooling impact on the planet. But some of these aerosols are actually a big warming source. So soot that's emitted from diesel combustion can actually warm the atmosphere. They're actually important for our natural climate system. Without them, we wouldn't have clouds or precipitation. And because of this, because of their ability to seed clouds in the atmosphere, they can have a cooling impact through that process. And then finally, aerosols deposit things like phosphorus or iron, which are nutrients that can fertilize the oceans and the tropical forests, such as the Amazon basin. That's something that we study in my group. What this does is this causes plants to photosynthesize and they draw down carbon dioxide. So this is a way of cooling the planet naturally. But because of these positive and negative impacts, combined with the fact that we don't understand aerosols nearly as well as greenhouse gases, they're harder to measure. They're not as globally homogeneous, meaning they're not as globally spread out. We understand their impacts a lot less. In fact, the aerosol impacts on clouds remain today the largest source of uncertainty with respect to global climate change. So if you ask me how much temperature or how much warming can we expect in the future atmosphere, we're unable to give a very precise answer because we don't understand the impacts of aerosols. So if you want to predict the future better, you really need to understand the impacts of aerosols better. And this is why I chose to study them, actually. In terms of what we can do, basic things like using technologies that reduce particles are good, not just for climate, but also for human health. So some examples is, having, for those of you who might burn some sort of, or use a truck or a car that uses diesel, there's particle filters that can catch the particles before they go into the atmosphere. There's also ways that you can filter out particles from, say, like a cooking stove. So we have the technologies to reduce the particle emissions. It's just a matter of actually implementing them. Yeah.
Now, something else that you mentioned earlier, which I thought was fascinating, and it got a lot of media attention in the past, Saharan dust, and how that blows over from Africa. How does it impact our climate, hurricanes, human health here in South Florida?
Yeah. So for those of you who live in South Florida, you're probably experts on Saharan dust as well. You see it when it comes over in the summertime. It kind of can tinge the sky a little bit. And sometimes if there's a big dust event, you'll actually see like a reddish powder that develops maybe on the hood of your car. So this is dust that is transported from the Saharan desert. It actually doesn't just affect us here in South Florida. It makes its way to the Amazon as well as the Caribbean. And we study these particles here at Rasmus. We study them. We have a tower in Barbados, and we also have a measurement site in South America. So they have multiple impacts on the atmosphere. They affect clouds. We're still studying how they impact clouds in Barbados. This is something that my colleague Paquita Zaidama does at her Cloud Aerosol Rain Observatory at Rasmus. The dust also has a lot of phosphorus and iron, so it's thought to be a natural fertilizer from the Amazon rainforest and the Atlantic Ocean. And those are both major carbon sinks. The dust is also thought to potentially supply nutrients, though, that can also facilitate the red tides that we get on the west coast of Florida. So both positive and negative impacts. When the dust comes to South Florida, sometimes you'll see an advisory that it may not be safe to go outside because the dust is thought to have negative health impacts, like triggering asthmatic responses. But we still don't fully understand, honestly, those impacts in terms of health. In terms of hurricanes, when the dust blows over the ocean, it's usually contained in a hot, very dry layer of desert air. And that's thought to reduce tropical cyclones. But again, we're still studying just how dust can impact those hurricanes. And that's something that one of my colleagues, Jason Dunyan at NOAA, who's a collaborator of mine, is very interested in this topic.
Very, very interesting indeed. And then going back to global warming, I think something that many people don't understand is that the Earth's atmosphere has been cycling in terms of temperature for millions of years, up and down, and so how much of the current increase in temperature that we're seeing, whatever it might be, 1 degree every 10 years or so, how much is that due to the natural cycling of the Earth's temperature versus man-made impacts?
Yeah, so most of the temperature increase that we've seen has actually been from man-made impacts. And we know this for two reasons. One is if we physically model what's going on with the Earth's atmosphere, we can't get models to predict current temperature trends that we're seeing without inducing an anthropogenic impact. So that's one way that we know that. The second way is where atmospheric chemists come in. So one thing that we do is, I mentioned we fingerprint those greenhouse gases, and we can do that with carbon dioxide, for example. So it's very akin to carbon dating, where you basically can look at how carbon, which usually has a certain signature to it, associated with plant material, is being increased in the atmosphere. And then also we're seeing old carbon signatures. So like with carbon dating, we use radiocarbon, which has a certain decay cycle to it. We essentially are seeing decreases in radiocarbon in the atmosphere, which indicates that something, the carbon buildup that we're seeing in the atmosphere is something extremely old that was also plant material. And that matches the signature of fossil fuels. So those two lines of evidence from both the physical point of view and the chemical point of view lead us to conclude that most of the warming that we're seeing, unfortunately, is human induced.
Now, can we actually stop global warming or just slow it down?
Yeah, again, this is another question that would probably be best suited for some of my other colleagues at the Rosenstiel School who are trying to model some of these things. But yeah, it is going to take a long time to stop it. I mean, we can slow it down by reducing our carbon footprint. But because these greenhouse gases, the reason they're so easy to study is because they have a long lifetime in the atmosphere. Meaning that it's going to take a while before we see major decreases in climate change, even after we've reduced carbon emissions. Now, that can be a bit of a disappointing answer to hear, but the way I always think about it is, what kind of planet do we want to leave for future generations? We want our future generations, our children, our grandchildren, to enjoy the same things that we've had the fortune of enjoying too.
And looking ahead, right? I mean, we all want to make a difference, but in your opinion, what are the biggest hurdles for the human race in terms of battling global warming? Is it just a political challenge? Is it a cultural challenge? What are the biggest hurdles, in your opinion, to tackling global warming and climate change?
I think there definitely is a cultural and a political challenge, but I think one of the bigger issues that I personally think is, I think that there's just a lack of communication. I think it's hard for people to be invested in this issue if they don't understand the science. And I think part of that is, making the science more accessible, making it integrated throughout, through different levels of education. And then also, I think the conversation has for too long been just strictly at the scientific level. And I think, it's time for, the entire population to have, more of their voice being heard in climate change. I can talk as much as you want about, my expertise in climate change, but I really think what's going to drive, real tangible impetus to fix this issue is going to be, the stories that people have of my house burned down in a wildfire, or, I lost my home from a hurricane. I think that's what's really going to, change the playing field on this issue. And I think, unfortunately those stories, but combined with, empowering people through, better science communication and more education, I think is the way to really make a dent in this issue.
Yeah, I mean, I really agree with you. I think that it's almost an ignorance is what I'm seeing, in the sense that, just like you said, people don't want to hear science. I think what's going to make a difference are actual personal stories, and having people understand what are the impact of their decisions. I mean, and this will be the last question because I know that you're super busy, but maybe just paint a picture for us. How critical is it that as a human race, we make these changes and we make climate change and global warming a real priority? Meaning, like, what will be the ultimate outcome 10, 50, 200 years down the road if we don't make these changes, if we ignore global warming
Mhm.
and we just say, well, it won't be an issue?
Yeah,
Hello?
I mean, I think we're already starting to see the possible glimpse of the future if we don't deal with this issue. The new normal of an increased fire season increases the probability that either those of us who live on the West Coast or those of us who have loved ones on the West Coast are going to have their house burned down. My family is living in California right now, and I worry about that. Every time this time of year, are my parents gonna have to start all over again? For those of us who live on the East Coast, how many hurricanes are we gonna have to weather? How many of these storms that just sit over us and just keep dumping water and more water? Is that really the future that we want? And also, is it the future that we want our kids and our grandkids to have? I think that's sort of the way of thinking about how urgent of an issue this is. Um, and getting back to your point about the education, I think part of the issue isn't just about, science and people, I guess you said like ignorance about science. It's also just, I don't think that the scientific community has done the best job of communicating. And, for me personally, like if someone starts talking about something and I can't understand it, it's hard for me to care about that issue, you know? And so I guess, I think it's also on the scientific community to think about, how would you explain this to your family? Treat the public as you would members of your own family. How would you want them to care about this issue? How would you explain it to them? So that they understand it a bit better and can make more informed choices on their daily lives and also when voting.
Yeah, I mean, I think just like you said, people need to understand this is not something, 1,000 years down the road. This is now. This is affecting people now, and the problem is only going to get worse, and it's going to be just a huge global impact as it continues to propagate. So, again, thank you for your time, Cassie. Amazing work that you're doing over at the Rosen Steel School. You and all your colleagues. Thank you for all your time working on all these important topics. And again, thanks for your time this afternoon. It was really enlightening to talk to you, and I really appreciate it.
Thank you so much for having me. It was a pleasure to just talk to you as well. Take care.
All right, Cassie, take care. Have a great weekend.
You too. Bye.